Yo, Algebra 2, what's crack-a-lack? And this is Tearing It Up, a.k.a. Mr. Taryn, rocking with you today. And what we're going to look at here is we are going to start our unit on sequences and series. So the first thing we're going to look at sequences, and then a few videos down the road we'll take a look at series. Before we can talk about sequences, and eventually we're going to get to what's called the recursive formula, we got to understand, what is a sequence? Well, a sequence is just an ordered set of numbers with some sort of a pattern. So if we look here at the first one, 1 to 4, 4 to 7, 7 to 10, 10 to 13. Obviously, we're just adding 3 every time, so the next two numbers would just be 16 and 19, okay? This one's a little bit different here. It looks like these are perfect squares. 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, so on and so forth. But, so 6 squared is 36, 7 squared is 49. So that's just what sequences are. It's just kind of these ordered numbers that have a pattern. We're going to keep rolling here. We just said a sequence is an ordered set of numbers, so we basically got to find the pattern and then figure out what's next. But we're going to jump into recursive sequences. So today we're going to be talking about recursive, or I guess this first section really is going to be recursive and explicit formulas. I know those words sound really weird because they are weird words, but trust me, it'll all make sense. We're going to start with the recursive formula. And when we're talking about that, it's always important to keep in mind that there are two parts. The first part is literally telling us the value of the first term. So in a minute, you're going to be asked to give like the first 5 terms of a sequence. The first part is literally the answer to the first term, so make sure you understand that. The second part is like the rule that we're going to use to find each term past the first. And when we're doing recursive, in order to do this, you have to know the first term. And then what we do is we use that term to plug in to find the second term. Once we find the second term, then we're going to plug in to find the third term. Once we find the third term, we're going to plug in to find the fourth term, so on and so forth. Okay? So let me show you what this recursive formula is like. This is extremely important in this slide, so make sure you have this in your notes. But essentially, recursive, you're going to know that it's a recursive formula because it has 2 parts. It's always going to have this first part, and all this first part is saying is that A1, which means your first term, equals 10. Okay, so your first term, A1, equals 10. And then the second part of the recursive formula is your actual rule. Remember I said the first part was literally telling you what the first term is? That's this part. The second part is the rule to find each term after that. So what this one means, this part right here, this AN, that just means the value of any term is equal to, let's cross this out. I don't like that. Whenever you see this, and it should be written like this, AN minus 1 down there, please stop trying to plug in numbers for n. Just think about this as the previous term. I don't want anything else going into your brain than the previous term. So when we look at this, we can say the value of any term is equal to the previous term plus 30. So that's just the rule, okay? I know this probably still looks super confusing. The best way to do this is to go through a couple examples. So here we go. Let's just run right into one. There's the answers, but we're going to find these answers ourselves, okay? So find the first 5 terms using the recursive formula. Well, I'm just going to put those right up here. Those are my 5 terms. I know that my first term is equal to 34 because it is literally telling me that right here. And then in order to find the next terms, all we're going to do is take the previous term and subtract 6. So how this would look is we would say A2 2, which is this part, just means the second term is equal to the previous term. In this case, our previous term was 34 minus 6. And 34 take away 6 would be 28. So A2 is equal to 28. Now we need to find the third term. So in order to find the third term, we're going to take the previous term, in this case it was 28, take away 6, and that's equal to 22. Now we're going to find the fourth term. Again, in order to find the fourth term, we need to use the third term, the previous term, which was a 22. Take away 6, because that's our rule, and I get 16. For the fifth term, again, previous term, which is 16, minus 6 is 10. And that's all it is. That's all it is for recursive formula. You're just taking the previous term and you're doing whatever the rule says, and it will always give you the first term. We can run through maybe one more example, and we'll call this video done. At this point, if you would like to pause the video and try this one on your own, go for it. I'm going to go through the solution right now. So again, I'm going to make these five little, and I'm going to do, I know my first term is a 5 because it says that right here. So here we go. So to find A2, all I'm going to do is I'm going to go 2 times. Remember, this just means your previous term. In this case, it was my 5 plus 5, which equals 2 times 5 is 10 plus 5 is 15. To find A3, we're going to go 2 times my previous term, which was a 15. 2 times 15 is 30 plus 5 is 35. To find my fourth term, we're going to go 2 times my previous term. Again, my previous term was that 35. So 2 times 35 is 70, plus 5 is 75. And to find my fifth term, again, I'm going to take 2 times my previous term, which in this case was 75. 2 times 75 is 150, plus 5 is 155. And that's it. That's all there is to it. So hopefully this was a good video for you to understand recursive formula. Just please make sure, for recursive formula, it's 2 parts. Know that it's always going to give you this first term every single time, and know that A subscript n-1 just means previous term, and you should be good to go. That's all I got for now. It was great rocking with you, Algebra 2. Have a nice day.